I have 7 years. Now our analyzer was exported to 39 countries, different kind of application: biogas, automobile gas, gasifier, and flue gas, and so on, like that. And for medical gas application. How to use that? This one.
The arrow keys don't work.
Okay, now here is our new company here. At the beginning we have nothing, we just have some idea. Now after 7 years, now we have industry here. This about 20,000 square meters for the land and the building also. So I tell you about something about Cubic. So in Cubic, we have developed 3 kind of technology. One is the NDIR, and another one is the MEMS-based TCD technology, and the third one is the TCD electric chemical detector. This kind of technology we just buy from Japan because it's some cheap just for oxygen. So in our whole gas analyzer, the produced gas analyzer, this is the 2 kind of main technology in the gas analyzer. NDIR in fact is a traditional way for analysis of the CO, CO2, CH4, SO2, NO, and so on. The principle is very simple, that different kind of gas have different kind of wavelengths for absorption. For example, for CH4, just about 3.3 UM. For CO, generally 4.2. For CO2, for CO 4.64. And CH4 also has some another absorption peak where in other area. So firstly, for the gasifier, we should analyze the CO and the CO2. It seems very easy, but in fact, not so easy. At the beginning, we developed this kind of analyzer. I think it's very easy, and shipped to the university in China who do this kind of research in the university. He found some many problems. It's some different with the GC. He told me why. I don't know. At that time, after 7 years, after 1 year, I think after 1 to 2 years, I found that there's some problem that I had to test different kind of the cylinder gas. I found the problem. The problem is that here, yes, CO and the CO2 is different in the peak, but in sometimes it kiss each other. Here, it's like the channels that touch each other. So here, if the peak of the peak wave is you choose is some different. Near that, they have some cost sensitivity. CO has some talking to the CO2, and CO2 also has some cross talking to the CO. This is some problem. So the selection of the filter for that detector is very, very important. For this kind of for gasifier and processed gas, the produced gas, we use this kind of filter. So filter selection is very, very important. So if you buy a generally NDIR CO and CO2 bench, you see you can use that. In fact, no. Sometimes the problem. This is the reason of the cross sensitivity. So this is our one experience how to use the different kind of CO and the CO2 sensor. Okay. After solve the problem with CO and CO2, The second problem is the CH4. The difference of the CH4 in different kind of gas is that in produced gas, in gasifier and the Paragus gas, inside this one gas, besides the CH4, they have another kind of hydrocarbon, the C2, C3, C2H4, C2H6, and so on, C3H6, and so on. This kind of gas have also cross-sensitive to metal. How to analyze that? You see that this is the ethanol, C2. This is the C2. This one is the methanol. You can see that the C2 and the C3 have the series cross-docking to the methanol. So if there are some, especially for the biochar process, the C2 plus is more than 2%. At this level, CH4 maybe sometimes more than 100%. In fact, just maybe 20%. It takes 100%. So CH4 in this situation is some difficult to analyze it. So for how to get the CH4 reading? So this I found that in fact yes, C2 plus have a series cross-talking to CH4, but I don't want to analyze this peak. So I use another one. Here is the cross-sensitive, you know that. Here is the methanol. Here you see just 1%, the decay 10%. So if there are 2% of the C plus, maybe 20% methanol disappear here. So it's totally wrong for the CH4. So we should choose another filter for this CH4. Here we found the CH4 here the main peak for absorption, but the CH4 also have another absorption peak here. Here have no cross-sensitive of the C2 plus. So we choose this kind of filter for CH4. This kind of filter for CH4. So this is no cross-sensitive, or less cross-sensitive to C plus. This is the reason why we can analyze the CH4 in different kind of hydrocarbon, especially for the biochar process, charcoal process. This is our testing of the different kind of the gas. CH4 100%. You see that is 100%. C2 here no cross-sensitive to CH4. C3 have very less. C4 also very less. So CH4 reading is perfect. So it's very nice for the for gasifier or for charcoal process, biochar process, and so on. So we solve the problem the CO, CO2, and CH4. And then another problem the CnHn. CnHn. Is a new technology. For CnHn, we found we had tested different kind of the filter. Which one is the best one for the CnHn? CnHn means that if you input the CH4, they have less reading. You input the C2 and then C2. If you input the C3 and then reading is C3. So we found that 3.46 this filter is the best filter for the CnHn. This is our testing. You can see that they also have some cost sensitive to the CH4 CnHn. So we had tested different kind of the input different kind of gas combination of the C1 and C3. We found the different kind of test that. So we should do some correction on the reading of the CnHn. So by this way, we solve the problem with the NDIR for CO, CO2, CH4, and CnHn. So we found this problem. And then the next one is the H2. H2 for the purified H2. Sorry.
I'm sorry, I missed what the correction. How do you establish the correction for
CnHn?
Your last slide, you mentioned that you had one, but what is it? How do you apply it?
CNHM means that firstly we should read the CH4. After we know the CH4, how much CH4 have the cost sensitive to CNHM, then we can know. We can buy the regulation function to know the CNHM. I don't know whether or not I can explain to you.
Regression analysis.
Yeah. Because now is the input. There is the input. Here is the output for the reading, and then do the correction. Do you understand what I mean?
I think so.
Okay. So my bad language. Yeah. Okay. The last one problem is for the H2. H2 is very important. Very important. So the TCD technology for the H2 is a very simple technology. So you can buy H2 analyzer in the market. I think maybe $2,000 is enough there. But sometimes for gas file and the batch process, there's some problems there. Because, sorry?
Does CO have conductivity similar to oxygen or carbon dioxide?
CO
Yeah.
have
Conductivity?
Yeah.
Conductivity. Is it similar?
to nitrogen.
Yeah.
Yes.
Okay.
So CO have no serious problem to H2.
Yeah.
The serious problem is the CH4 and the CO2. You know so that CO2 here
Yeah.
14 and the CH4 for 13. So CH4 will increase the H2. CO2 will decrease the H2. So if we vary the CO2 and the CH4, and the reading of the H2 is wrong. So we should do some compensation. Because we have NDIR, it's no problem for us. If we have no NDIR, just H2, how to know that? This is the reason we should combination of the NDIR and the TCD together. This reason I don't know whether or not I can explain clearly. So this is the problem of that. With the combination of the TCD, H2, and also 3 NDIR, and then we can do the collection of the H2 by this way. See, K zero maybe sometimes zero because the CO have no serious effect on the H2, but the CO2 and the CH4 they have some problem to H2. So generally, see, I know as my imagination that CH4 just 5%. 5%. For example, 1%, 100%, we give 5% of the H2 reading. CO2 maybe 10%, just by different kind of sensor technology. So NDIR and TCD together, we can get the H2 correctly. So accept the H2 sensor cannot get a good result testing of the two in produced gas and also for biochar process. Okay, by this way, we know the 4 gas of the NDIR and then the correct H2 and O2 is simple because you use the electrochemical detector. It's easy to do that. By this way, we can know the heating volume of the gas. Formally, is a difficult way to get this kind of parameters.